4.1, graphing quadratic functions. We will now be graphing equations that have an x squared in them, which you can see right here. This is our quadratic function, ax squared plus bx plus c. All of our graphs will look like the letter u. It'll be u, a regular u, or it'll be an upside down u, all dependent on your a value. So first we're going to start off simple, graph the function using a table. So let's just pick a couple points here. We'll do this quickly. You're not going to always graph by a table. This is our only time. So let's pick -1, 0, and 1. So 2, -1 squared minus 8 times -1 plus 5. So that gets you 2 plus 8 plus 5. So that's 10, that's 15. This point right here is -1, 15. 0 is 2 times 0 squared plus 8 times 0 plus 5. So that's 5. This point here is 0, 5. And 2 times 1 squared minus 8 times 1 plus 5. This gets you 2 minus 8 plus 5. Okay, so this is -6 plus 5 is -1. So this is 1, -1. So if we wanted to graph something like this, again, I'm going to roughly do it. Let's say -1 is here, and we'll say 15 is up here. So here's my first point. Next is 0, 5, 1, 2, 3, 4, 5. There's my next point, 1, okay, and -1. Okay, so right now, we only have this part of the graph. See, what's interesting is eventually the graph will come back up. So that's why graphing using a table isn't always awesome. You could try 2 as well. Let's try 2. So you have 2 times 2 squared minus 8 times 2 plus 5. That's 2 squared is 4 times 2 is 8. 8 minus 16 plus 5. -8. -8 plus 5 is -3. So this is 2, -3. So it's going to go down even more, right? And again, eventually it'll shoot back up this way. Now I'm not sure where, and this is where we're going to begin. So you can see that by picking points is hard, okay? Because you're not sure what points to pick to figure out what this bottom value is. So let's look at an easier way. Now, an easier way, you do have to follow these steps. So write these steps down. Okay, so you're going to graph y is equal to ax squared plus bx plus c. Okay, we have this thing right here called the axis of symmetry. Axis of symmetry is equal to x equals -b over 2a. You need to memorize that. A lot of times I will abbreviate it like this. AOS is x equals -b over 2a. Now, the axis of symmetry, okay, is a line, and it's this red dotted line right here. That's my axis of symmetry. It cuts my parabola. It cuts my u in half. Okay, so it's equal distance on both sides. Now, in order to figure out where the graph bottoms out or finishes is down here, and that's what we call our vertex. And we've talked about vertex before. Now, how do you find the vertex? Well, first, you already know the x. The x comes from the axis of symmetry. This is the axis of symmetry, is your x of your vertex. Now, the y, the way you find the y in is you plug the axis of symmetry back into the equation. And that's what gets you your y value. Okay, so you have your axis of symmetry. It's a point. You have your vertex, which is a point. You have your axis of symmetry that goes through the vertex. Okay. Then the last thing, you always want to find your y-intercept. That's very easy to find. To find your y-intercept, which is right here, this very first line. That y-intercept is, the easiest way to say it, 0, c. So you want to figure out what 0, c is. All right, so let's look and start working. Now notice this number 6 we just did up above where we had to pick points and it was a little bit harder. So A says find the y-intercept, find the axis of symmetry, and the x-coordinate of the vertex. Okay, and then it says use a table of values that include the vertex and use the information to graph it. So I'm going to take out this table. We're not going to do a table anymore because I just told you the steps up above. So please write these steps down. Step 1, you're going to find the axis of symmetry. Which is x equals negative b over 2a. So remember, a, b, c goes in alphabetical order. Negative times negative 8 over 2a times 2. So this is 8 over 4, which is 2. Our axis of symmetry is x is equal to 2. Now, if I start graphing that, my axis of symmetry, x equals 2. Well, 2 is right here, and it's a dotted line that goes through 2. You have to label it A, O, S, axis of symmetry. Step 2 is to find the vertex. Now remember, we already have the x of the vertex, 2, comma, let's figure out that y. And how do you do that? You plug it back in. So plug into the equation. So you have 2 times 2 squared minus 8 times 2 plus 5. 2 squared is 4. 4 times 2 is 8. 8 minus 16 plus 5. 8 minus 16 is negative 8 plus 5, which is negative 3. Okay, so here is my vertex, 2, negative 3. So go to 2, go down to negative 3. It's right there. Now I want you to put a V next to it for vertex. Okay, this is really important. If your vertex is not on the axis of symmetry, you've done something wrong. You need to go back. Okay, and then last step, which is the easiest step, I think, to do, is you want to find, so step 3, find the y-intercept, which is going to go on the y line. That is 0, comma, c. So 0, comma, let's look up here. C is the very last one, your constant, 5. So go graph that. 1, 2, 3, 4, 5. There it is. Okay, so look. Right now, I have this much of my graph. Okay. Now, I said it has to look like a U. So how do I get the other side? Okay. And here's how. I'm not just going to draw it. Okay. The distance between your y-intercept and your axis of symmetry is the same. So the distance from here to here has to be the same as the distance from here to the other point on this side. Okay? From here to here. So let's look at that. This is at 0 and this is at 2. So we're 2 units away. Okay, we're 2 units away, so we want to go 2 units on this side, which puts us at 4. Again, 2 units on this side. So equal distance, okay? So now what I'm able to do is to finish my graph off. I start here, I come down, I swoop through my vertex, and I go back up there. Okay, so what am I looking for on your homework? You don't have to do these swoops, right? But I do need the axis of symmetry, and I need it labeled A, O, S. I need your vertex labeled with the V, and I need your actual view of the graph. All right, let's move on. Let's look at this one. Now, look at the A value. Okay, what you should notice here is that our A value is negative. As soon as you see that it's negative, my U should now be upside down. Okay, so let's check that out. Step 1, axis of symmetry, x equals negative b over 2a. x equals negative 6 over 2 times negative 1, which gets us 3. So again, I'm going to start my graph. My axis of symmetry, x equals 3. Okay. AOS. All right, next, let's find the vertex. Right, so we already have the 3. What is the y? Negative 3 x squared plus 6 times 3 minus 1. Now, the 3, you have to square the 3 first, which is 9, and then you bring the negative down. So negative 9 plus 18 minus 1. So negative 9 plus 18 is 9 minus 1, which is 8. This is 3, 8. Seven, 8. Okay. So 3, 8. It's all the way up here. This is my vertex. Again, it has to be on the axis of symmetry, which it is if I just extended the axis of symmetry out a little bit more. Okay. Now, lastly, my y-intercept. My step 3, my y-intercept, okay, which is 0, comma c. So 0, comma negative 1. Well, that's all the way down here, which is good. We're going to get a nice looking graph. Okay, so to find the other side of our graph, you'll notice you're always going to be adjusting your graph according to where your stuff is. So this y-intercept right here is 1, 2, 3 units away. So now you need to go 3 units on the other side. 1, 2, 3. There it is. There's my point. And connect those dots now. So we're coming down this way. And you're coming down this way. And there is my parabola. Now, the next thing talks about max or min value. So the maximum or minimum value is at the top or the bottom. So if we look at what we just did, okay, if you notice, if I would say, okay, at the top, up here at the vertex, is this a maximum or a minimum? Or a minimum? If anything's at the top, this is going to be maximum. This is a maximum value graph, okay, because it's at the top. So let's talk a little bit more about maximum and minimum. So when you have the maximum or minimum of a graph, if the graph is a regular U, it's going to be a minimum value, okay, because the vertex is at the bottom. Okay, so here, this is a minimum value because the vertex is at the bottom, minimum. If you have a maximum value, the vertex is at the top, so it's maximum. Now, when it asks you for the value, you want to write this down, maybe make it a thought bubble. The value is the y of your vertex. Okay, so the x of your vertex is the axis of symmetry. The y of your vertex is the maximum or minimum value. Okay, so it says determine the maximum or minimum value here. Well, here's what's interesting. In order to figure out what the minimum or maximum value is, you have to find the vertex, okay? So how do you find the vertex? Well, that's just step 1 and 2. So you need to do step 1 and step 2. Okay, so this one, step 1, axis of symmetry, x equals negative b over 2a. Well, negative, there's no b, 0, over 2 times 6. This is just 0. And then you have to find your vertex, step 2. Okay, so this is -6 times 0 squared. Well, that's just 0. So my vertex here is 0, 0. Okay, so you could tell me the value, but you have to tell me whether it's a minimum or maximum. Let's look at our A value. Our A value is negative. So again, you're going to write yourself a little thought bubble. Write yourself a little note for this one. Because it's negative, my U will be upside down, and the vertex would be at the top. And because the vertex is at the top, I'm going to have a maximum graph, and the value of this, y equals 0. Again, it's the y of your vertex. Let's look at number 9. So again, step 1, axis of symmetry. X equals negative b over 2a. Negative 8 over 2 times 3. Negative 8 over 6. And negative 4/3. Okay. This, of course, is going to give me a decimal or a fraction, right? So you would plug that into your calculator. You would probably plug the decimal in of your calculator. Okay? So you would want to figure out what that value is. But let's just talk about this in general. Because A is positive, my graph will be going up. It's regular, so I will have a minimum. Oops. Okay, graph, and the value will be y equals whatever we find in our calculator. All right, let's go to 4.2. So 4.2 is very similar to 4.1. You're going to be looking at the same graphs. They're all quadratic functions, but now you're going to tell me what x equals. So that means you're going to be going through and you're going to see where the x-axis is. So if you have a graph where it only hits once, and I'm looking at this box right here, we call it your roots or your zeros, okay? How many zeros do you have? For this first one, you will have one real solution because it only hits the graph once. The one in the middle, if it hits it twice, you'll have two real solutions. And if it doesn't hit your x-intercept at all, you have no real solutions. Now, it will say state the solution, so you'll say x is equal to whatever, okay? But that's what we need to know. So let's look at numbers 1, 2, and 3. Number 1, it says, use the related graph of each equation to determine the solutions. Well, here's my x-intercept. I would always highly recommend highlighting that. It never hits, so there's no real solutions. Make sure you say real solutions, because there is solutions, they're just imaginary, and we'll get to that in, I think, this chapter or next. Number 2, here's my x-intercept. Okay, so it hits twice, right there and right there. So you have two real solutions. Let's take it a step further. What do they equal? Well, what are your solutions? What are your zeros? X equals -2 and 5, because that's where it hits. Number 3 goes through, highlight that x-intercept. It hits once, so you have one real solution. And what's your answer? Where does it hit? Right there. What is that number? 1, 2, 3, 4. X equals -4. Okay, with these ones here, we're going to do these in class because I'm going to teach you guys how to graph. And what ends up happening with these graphs is if you graph it, let's say 1, 2, 3, 1, 2, 3, right? And again, I'm just making it up. I'm making this graph up. This says, well, what happens if it doesn't hit on the exact like whole number? This is what this state the consecutive integers between the roots are located, right? So something like this would be, well, there's two real solutions. And if they ask us what the real solutions are, because they want you to state the consecutive integers, consecutive means next, one next to each other. So the first one would be between 1 and 2, and then the other one would be between -1 and -2. But I'm going to show you more of an accurate way to do this on your calculator in class. Okay, that's it for 4.1 and 4.2.